If you want to quickly capture an exploration prospect from an image, like a PNG or JPEG, like this one, then we would use the Color Scan Trap Scan tool. This will generate the geometry, depth area pairs, and gross rock volume. So we'll have the prospect in GIS for a quick assessment and get exportable data for volumetric calculations in Excel or more detailed prospect evaluation software. Now, this is a depth structure map. There is a separate video on how to use the color scan tools to generate a GIS surface from this image. But here we're going to look at how to capture this prospect, which we can see has the extent defined by this blue line on this depth map. So the first thing you would do is add your image to your project, and then you could georeference it using the normal Pro georeferencing tools, which are available from the imagery ribbon. Color Scan does have a scaling tool, which means you can do things without georeferencing, and that's if you want to do things quickly. And we'll look at that later. But this image has already been georeferenced, so it's in the correct location. So the next thing we would do is go to the Color Scan ribbon. We would select the image from the drop down so that it's the image we're going to work with. Then we would select the Trap Scan tool, which is the tool we're going to use to capture the prospect. And what we're actually going to do here is we're going to be calculating the area for each contour level. So we want to start at the top and work our way down in sequence. So if we just zoom into this prospect, so the first thing we want to do is close off any gaps we've got in the contours. So for example, where we've got the depth label. And the way we do this is to use this barrier tool. And we use this to just digitize lines wherever we've got a gap in the contour. And we want to get a solid border all the way around the contour so we can calculate an area. And to calculate an area, we're going to use the auto capture tool, and we're just going to use this to create a single mouse click anywhere within the contour, again starting at the highest point first. So a single mouse click, and then we create a polygon, and we get one row added to the table, and that's showing us the area for that polygon. Now, as we can see from this image, it's quite a complex image. It's got some noise, it's got some lines, so the tool hasn't been able to discern exactly where the outer contour is, and we've got some pieces missing. So all we do to fill those is just go over there, and again another single click, and we can carry on doing this, filling all the gaps or any bits missing to create polygons wherever this depth is. And every time we create a polygon, it's actually merged with the previous. We always get the total area for all polygons, and every time a row is added. So we can see the last one here includes all the other polygons, and it's getting there. It's got a few holes in it, and we can actually use this manual digitize tool as well, just to digitize a patch over any holes, and that'll then give us a complete polygon. And then what we can do is we can just delete all the rest just to leave us with the last one. And the last one gives us a nice clean polygon covering the total area of our contour, and we've got an area for that. So now we can put in the depth values. So we do the crest first, so the depth above this contour, and then the actual contour value, and that will give us also a volume as well. So having done our first contour, we can now move on to the second contour, again just by using the auto capture tool with again a single mouse click, and that creates the polygon, and then we just keep going until we've captured all the areas for this depth. Again, we're always merging with the previous, so every polygon includes all other polygons, and again we might need to just use the manual digitize tool to create a patch, just to get rid of any holes in the polygon. And when we've done that, we will get a final polygon. So once again, we don't need all of the other polygons we've created, so we can just keep our final one and just select the other ones and delete those. So having put in the next contour depth, we can just repeat the process for the final depth, just clicking anywhere we need to cover for the final depth, and every time we click we get a polygon, and that's always merged with the previous. So we just need the final polygon, so we can select anything above it for the depth and delete those. This one still has a few holes in it, so depending how particular you are, you can just use the manual digitize tool to digitize a patch over that. And now we've got our final polygon at the lowest depth for the prospect, and that's going to be the largest polygon, and it's going to show us the total area as well as the cumulative volume, which is a GRV in effect. So we can use this final polygon, the number 3 polygon there. Select the layer. This one has been added to the project. Now check Save Selected Only if you only want to save the final polygon that defines the full extent of the prospect. If left unchecked, a polygon will be created for every contour interval. You can also save the depth, area and volume values as attributes in the layer, although we'll leave that here. So click Save to create the prospect polygon in the selected layer. Now, as well as storing the values in the layer attributes, you can also copy the depth area pairs directly into Excel or other prospect evaluation software for further analysis. Now, so far we've been capturing the prospect from a georeferenced image. However, if you simply want to estimate the size of a prospect, calculating its depth, area and volume, without spending time georeferencing the image, or if the image can't be georeferenced because it lacks sufficient location information, then that can also be done with TrapScan, and we'll look at how to do that next. We just add our image to the project. Now we don't want to create any pyramids or anything, so we're just going to add it. And we get the warning in the top right saying unknown coordinate system because it hasn't been georeferenced. And so we then just select it from our color scan drop down just to make it the active raster, the image we're working with. Go back to TrapScan and you'll see here we've got this tool, Scale the Active Raster. So we just activate that, and it's not displayed at the moment because it's not georeferenced, so we're just going to hit the Fit to Display button, and that's just going to place it on the screen whatever we're zoomed into, so it's now on the screen to work with. And then we'll go to this tool, Draw a Scale Line. So we activate that, and we're going to use that to place one click at the start of the scale and then double click at the end of the scale. And then we just put the measurement for whatever the scale is, in this case 1 kilometer, and then hit the scale button, and that will actually scale it. So we're now in the right proportions. We're not in the right place, but we're in the right proportions. So we can then go back to TrapScan and we can carry on using TrapScan using the same workflow we used before to capture the depth area values.